Super Spreader Seminar Series of this year. And before I proceed further, I would like to acknowledge that the land of the OMNI network and its head office is located on the York University that recognizes many indigenous nations that have long-standing relationships with the territories upon which York University campuses are located that precede the establishment of York University. About the Super Spreader Seminar Series, this series is basically built for highly qualified personnel such as postdocs and graduate students to share their research, promote their ideas, and build a network of their own. And OMNI is a big network, so we have a lot of postdocs and there's a lot of scope for interaction between different students and postdocs. So today I would like to introduce our speaker, Dr. Isha Berry. Dr. Isha Berry has a BSc from McGill University and a MSc in Epidemiology from London School of Hygiene and Tropical Medicine. She has recently finished her Ph.D. in Epidemiology from University of Toronto. And her focus of her PhD dissertation was on understanding the transmission dynamics of influenza and avian influenza between humans and poultry in an urban setting in Bangladesh. So without further ado, I would like to invite Dr. Isha Berry to give her talk. Thank you.
Great, let me get my screens all set up. Okay. So okay, sorry, let me get this. Can you see? Oh no, this is the wrong way around. Sorry, I feel like I've gotten so used to Teams that I'm not adept on Zoom anymore. All right, can everybody see my screen and hear me?
Yep.
Yes.
And if I put this on presenter mode, can you still see the screen and can you see not the notes and just the actual screen?
Yes.
Okay. Yes, sorry, thumbs up. Perfect. Okay, great. So I'll get started. Let me get this over here. So here we go. All right. So good morning, everyone. And thank you so much for being here. So I know this is hopefully something of interest to everybody. I know a lot of folks come from a modeling background. So I'm going to be talking a little bit about some of the work that I did for my PhD and some of the work that is kind of ongoing. And I think as everyone kind of knows, you finish one thing in academia and then things kind of just keep spilling over. So this is some of that work. And so I want to also just start off by saying that some of this work is still in progress. So really, truly, this is going to be kind of a collaborative session. I'm hoping to get your feedback and your thoughts on some of this work and directions that this might go in and sort of how to best make this the most useful and impactful. So I'll start off by just before diving in to give a brief overview of what I'll be covering. So I'll begin with a background on influenza and avian influenza and Bangladesh to give sort of a context for where the study occurred, and then go over the aim of this project and some of the sort of sub-research studies that kind of led to where this is at. And then I'll wrap up with some points on this sort of methodological considerations and significance and conclusion, and really open it up for discussion at the end to get your thoughts. So to get us started, just a bit about influenza. So influenza is an acute viral respiratory infection, and it's a major cause of morbidity and mortality worldwide. And the WHO estimates that there are about 1 billion infections and 500,000 deaths annually due to influenza. And these are pre-pandemic numbers, of course. And influenza viruses are classified into 4 different types. So as indicated on the figure on the left, and the focus of most research, including mine, has really been on influenza A's, which not only infect humans, but also a variety of animals, including birds. And in birds, these circulating influenzas are known as avian influenza viruses, or AIVs for short. And broadly speaking, what makes influenza really quite interesting is that it has a propensity to mutate. So minor changes from year to year occur through a process known as antigenic drift, but major changes such as reassortment between circulating strains in humans and birds occur through a process known as antigenic shift. And this is really the primary driver of pandemic strain emergence and viral spillover. And looking historically, the majority of pandemic strains in the last century have had an avian origin. And this is really why AIVs are so important for research. And recent high-profile zoonotic influenza strains include H5N1, H7N9, and H9N2. In particular, H5N1 has had a resurgence in the last sort of couple years, particularly in poultry, and it's had devastating health consequences as well as economic impacts. And in humans, AIVs also have a high case fatality rate. So these estimates can range for highly pathogenic strains from 30 to over 50%. And in terms of transmission, there are a couple of different ways AIVs can spread from poultry to humans. So the major risk factor for transmission is contact with infected poultry. And this can occur through indirect exposure, such as at live poultry markets or LPMs, or through direct contact, such as when individuals are touching infected poultry. And this can occur during different practices, such as slaughtering or involvement in other food preparation practices. And this is, of course, only highly amplified in the context of low biosecurity measures. I also want to provide a bit of context on Bangladesh. So Bangladesh is located in South Asia, and it's classified as a lower middle income country by the World Bank. It has a hot, humid climate. And overall, Bangladesh is important. It's an important setting to examine influenza and avian influenza because it has a very high population density and a rapidly expanding poultry production sector that includes a complex web of backyard farmers, commercial farms, local traders, middlemen, and poultry market workers. And Bangladesh has a very wide variety of food systems interfaces, including live poultry markets. And in fact, over 90% of poultry are marketed through LPMs in Bangladesh, where AIVs are known to be endemic. And unlike other parts of Asia, such as Vietnam, Thailand, and China, there's been a lot less global research examining influenza pandemic emergence in Bangladesh, despite knowing that seasonal influenzas and AIVs co-circulate in this setting. And I don't think I need to go too much into this because I know everybody here has an interest in One Health, but I just want to make sure we're all on the same page. So One Health is a collaborative multidisciplinary effort working locally, nationally, and globally to obtain optimal health for humans, animals, and the environment, and understand the linkages between all of these different components and how they work towards overall better health. And so just to kind of recap what the really big gaps in our knowledge is despite the risk of AIV transmission and spillover in Bangladesh, there's relatively little known about poultry contact in the general urban population in this setting. There have been a couple of studies conducted, but they've been limited by results not being generalizable to urban populations or uncertainty about the small sample size and sampling frames, so things like that. And there's also been few modeling studies on AIV spillover that have been informed by empirical estimates. So there's been a lot of theoretical work, and I'll be honest, some of the work I'm doing today is quite theoretical as well, but having some empirical estimates to inform this is really important. And so the overarching aim of this work was to empirically examine pathways for transmission of influenza in human and poultry populations to better understand risks of AIV spillover and opportunities for control in Bangladesh. And, as you know, influenza and avian influenzas impact human and animal health, and their virology and ecology and epidemiology are shaped by interactions between humans, animals, and the environment. And in order to effectively prevent, respond, and control AIV and pandemic influenza, we need multidisciplinary approaches. And specifically to carry out my research, I brought together expertise from epidemiologists, veterinarians, physicians, and scientists across these various institutes in this One Health collaboration. And in the next sections, I'll go through each of the two key studies in more detail, beginning with a population survey to estimate the prevalence of poultry exposure in the population, and then using this information to inform a spillover modeling approach. So specifically for the first study, I aim to investigate the frequency and patterns of exposure to live poultry in LPMs and in the home among adults in Dhaka City Corporation, or DCC for short. And this included estimating the annual number of LPM visits and describing poultry handling behaviors and prevention practices overall and stratified by sex. And so this was a cross-sectional survey among adults living in DCC who have access to a mobile phone. So the sampling frame for this study was a list of phone numbers from each of Bangladesh's 4 mobile phone operators. And we sampled this in accordance to each operator's proportionate market share. So companies with higher subscriber rates contributed more numbers than those with lower rates. And from this, we conducted a single stage probability sampling design stratified by sex to recruit a minimum of 1,040 individuals. We used a sort of complex process, but essentially each phone number was called up to 4 times to establish contact and complete an interview. And we used a set of standard definitions to classify the call outcome status. And data were collected using a structured questionnaire that was based on previous poultry exposure surveys that had been conducted in China. And participant responses were entered in real time by the research team using a computer-assisted telephone interview system. So for instance, So specifically, the survey collected information on participant demographics, poultry purchasing practices, food preparation practices, and prevention practices. And so, for instance, one of the questions that was asked is approximately how often did you visit a live poultry market in the last year? So the options ranged from daily to once or twice a year or never. And this is really the key question that we use to estimate poultry contact in markets and the frequency of that. And then using the survey data, we weighted this according to the population demographics, and I estimated the prevalence of poultry exposure and poultry handling practices. And we also looked at chi-square tests to examine differences by sex. And we also assigned standardized midpoints for each visit category to estimate the mean annual number of visits. So this is in accordance with previous studies that have been done in other settings. And just to give people a bit of an idea of what this actually looked like in practice, so this was the study team in the center there. So we trained a lot of folks in Bangladesh in some of these research methods. And there was a lot of practice to ensure that the study team was comfortable asking the questions, conducting the interviews. And these are sort of the little phone booths that everybody was in to conduct this phone survey. So this is just trying to give you a little bit of an idea of what that process was like. And this was in 2019, so things have changed, but this is just to give an idea of what that looked like. And so in total, let's see. Oops, sorry, something has gotten cut off here. There we go. Oh, there we go. So in total, over 5,000 numbers were dialed. However, we couldn't establish contact with some people. Others were ineligible once they were screened, and some declined to participate. So in total, between September and November 2019, we completed 1,047 interviews. And then in terms of the respondent profile, The weighted sample was about 42% female. The majority of individuals were under age 35, and the average household size was about 4 to 5 members. So this is broadly representative of DCC. And before going to the results, I wanted to provide a little bit of context of what LPMs and poultry exposure looks like in this setting. So here we can see a typical LPM. So there's different types of poultry in the same area, including aquatic birds. And so for those that know a lot about AIV, putting ducks and chickens in the same area can be problematic for biosecurity. LPMs can also be in open air markets, and frequently many chickens are together in baskets, and many baskets will be in one stall. And finally, here's an example of a market worker and a customer who's purchasing poultry. So you can see very little biosecurity is actually being used. People are touching the poultry with their hands, and these are all live poultry or freshly slaughtered. So hopefully this gives a little bit of an idea of what poultry exposure looks like in practice to help interpret these results. So overall, we found that 74% of the population reported any poultry contact, including LPM visits or food preparation of live poultry in the past year. And when looking just at LPM visits, about half reported visiting an LPM in the past year. And this was more common amongst males than females. And amongst other high-risk practices such as defeathering, and evisceration, the frequency of exposure was significantly higher amongst females. And the average number of LPM visits was 30.2, but as you can see on the left, this was consistently higher amongst males than females across all age groups, and the greatest number of visits were recorded amongst individuals aged 35 to 44. We also looked at the frequency of purchasing different poultry types. So here, broiler and Sonali chickens were purchased more frequently, while ducks and geese were purchased least frequently. And this is important just because there are different AIV risks associated with different poultry types. And finally, in terms of prevention practices, we found that about 3/4 of the population reported consistent hand washing, though this was significantly higher amongst females than males. But there was very little or very low PPE use, with about 90 to 98% not reporting using gloves, aprons, or face masks. And just to flag again that this study was done in 2019, so before the COVID-19 pandemic. So practices could have changed since then. And the practices did vary a little bit by exposure type. And so the key takeaways from this sort of first study, which is really an empirical study, is that a large portion of the population has frequent exposure to poultry, including at LPMs where AIVs are endemic, and also that there are differences in poultry handling behaviors and transmission pathways. And knowing this, it really informed my next steps, which was creating a spillover model and to better understand what that theoretical spillover risk looks like. And so specifically, the aim was to develop a model that tracks influenza dynamics at the human-poultry interface in DCC in Bangladesh, and to estimate the risk of potential AIV spillover from poultry to humans, and evaluate the potential effectiveness of intervention strategies on reducing AIV spillover. And of note, Bangladesh has only reported 8 HPAI H5N1 human cases. They've reported quite a few more H9N2 cases, and no H7N9s. So we didn't really have a lot of human data to calibrate this to. So this really became more of a theoretical exercise. And we also know that detection rates and other sort of catching all of these cases can be a bit difficult in this setting. So mild cases or cases that don't necessarily report to healthcare facilities just may not be captured. So in terms of the methods, this was a mathematical modeling study using a compartmental transmission model. And so the parameters were really empirically informed from study 1, as well as drawing on expert opinion and literature reviews. So we started with building a human influenza model, which reflected the natural history of influenza. So this was an SEIIAR model, so really splitting between symptomatic and asymptomatic infectious individuals. And we fit this to influenza data from Dhaka for 2017. and to estimate the beta parameters, which was really the key thing that we wanted from this. And also the data that we were fitting to was from a Sentinel site. So we know that this is just a reporting fraction of all the cases that are actually happening. So what we really did was fit this to the detected influenza and then estimated reporting fraction as well. And this is based off of some work that was done by Enger, Bretson, and al. So I have those references at the end. And they did a really great study on this in Bangladesh in 2017. And so we sort of lifted their model and adapted it for our use. And then in terms of the poultry model side, what we really did is once we fit that human model, we integrated a spillover component, which was drawing from a stochastic Poisson process where the rate of spillover is drawn from a gamma distribution. And so instead of explicitly modeling avian influenza in poultry, we're really only evaluating spillover based on a framework, which I'll talk about in a second. And really what we did was run 1,000 simulations of this to kind of get an understanding of how frequently do spillover events occur in each run, and what does the size of that potential outbreak look like. And then we integrated different types of interventions. So a reduction of 5, 10, 25, and 50% in terms of reductions in transmission to see how that impacted spillover. And really a lot of this work goes into this theoretical area just because we don't have very good estimates for specific interventions and their effectiveness. So for instance, things like reducing, increasing cleaning in markets or, reducing contact. We don't know the exact reduction in spillover that would result in, or the exact reduction in transmission. So we kind of looked at this in a more theoretical way. And really the way that we thought about this poultry spillover component is drawing from this great paper, which is a unified framework for detecting for infection dynamics of zoonotic spillover and spread. So these spillover events, as noted in the paper, are introduced using a stochastic Poisson process and based on parameters informed by both previous study components, so the study one, as well as other sources. And not to get too much in the nitty gritty, but really what we did was that if you look here, this is the Poisson process. So spillover was really determined by a compilation of a couple of different things. So the number of susceptible humans at time t, the prevalence of infected poultry, the infection response efficiency, and the exposure to poultry. So we had a lot of this information. So number of susceptible humans, we used census estimates. For the prevalence of infected poultry, we used estimates from studies that have been conducted in live poultry markets in Dhaka. For the exposure to poultry, we used the empirical estimates from the first study. And then for the infection response efficiency, so this is really where we don't actually have a good estimate for this. Before something spills over, it's hard to say how efficient that virus will be. So what we did was theorize potential high and low efficiency base cases to see, what types of interventions would be needed if a novel virus spillover was high efficiency versus something that was lower efficiency. So this isn't the best figure. I was having a hard time with Excel and bringing all the results together from R. But what really is the key point here is in the red are the high efficiency scenarios and in blue are the low efficiency scenarios. So as you can see, when you have a virus that's more highly efficient, then you're going to have a higher chance of spillover. So these are the number of events a number of runs out of the 1,000 runs that were done for each scenario that resulted in spillover. And what we're trying to show here was that for each set of reductions, there's a determinate reduction in the number of events that spill over as well. So it's a little bit lost in this, but the key point here was that as you have a greater reduction will result in reduced spillover events, but you need a way higher reduction for highly efficient viruses than you do for low efficiency viruses. So really to kind of take away from this is that stronger interventions are needed to compensate for more efficient viruses. And overall, most spillover is a low probability but high consequence event. So what we really wanted to understand was out of the 1,000 runs, how many runs resulted in at least one case, how many runs resulted in 10 cases, and how many runs resulted in at least 100 cases. And what we really found was that if there was a spillover event, it tended to have a high impact, a lot of greater than 100 events. But when it did happen, it was a very small number out of 1,000. So only about 6 to 10% of runs in each scenario resulted in spillover. And again, this part of the study is where I'm working on right now and just kind of running all of these and building this together. So welcome your feedback and really recognizing that this is a work in progress. And sort of the conclusions we really had at this point were drawing mainly on the human-poultry interface and contact side, is that there's a lot of contact that's happening in Bangladesh, and this is high risk, particularly now that we know that AIV spillover or AIV the prevalence is very high. And we've seen this not only in Bangladesh, but in Europe and North America. There's been more frequent human H5N1 cases. For instance, in Ecuador, there was one recently as well. And then exposure at home and at LPMs does differ by sex. We didn't really capture this in our modeling aspect, but we did capture this in our empirical estimates. And there's high uptake of hygiene practices, but low PPE use. So really there's room for education and improvement to make a difference in reducing that transmission. And then really thinking about, because this high proportion of the population could be exposed to AIVs, we see that there are these high consequence but low probability events. And really thinking about interventions, stronger interventions are needed to see high impact events come down. If we had a low efficiency virus emerge, these events may not happen as frequently, but we also may not need as strong interventions to bring them down. And again, I just want to acknowledge there's a ton of people that were involved in this study. A particular thanks to Dr. Amy Greer, who's really been helping with the modeling side and who's been leading, answering all of my questions and making sure it all makes sense and working my way through this. So I'll stop there if you have any questions, and we can kind of open it for discussion.
Great talk, Isha. Thank you so much. So we have a question in the chat here. Are there chances of infection during transportation of live poultry from markets to home? If that's the case, then distance from home to the markets would be consequential.
Yeah, so I mean, it's kind of hard to say what specific, again, this is kind of theoretical. So my understanding from that question is, if they're, just contacting poultry generally outside of LPMs, is that kind of the question? I don't know who asked it.
I'm sorry, I couldn't hear you. Can you repeat?
Oh, I was just asking for clarification on your question.
So I was wondering that when people were moving from the markets to the homes and they were carrying the live poultry, there's the people who come in contact during this transit, are they affected, or is it during when there is the duration of contact?
Yeah, duration, that's a great question. So I don't think that there's really good, and correct me if I'm wrong from others, but I don't think there's really good evidence on that specific, transmission is like. But from my understanding, and what we know about AIVs, you do need to have kind of some sort of sustained contact, not just passive transient contact. So really, I mean, you saw those pictures, people are really in contact, they're touching, they're involved either in slaughtering. It's really through the viscera. That's kind of one of the main ways that H5N1 in particular is transmitted. And there's, there's a lot more to be done. And this is kind of an area that is very theoretical because we don't have a highly efficient virus right now. H5N1 is well adapted to poultry and ducks and their GI tracts, and not really well adapted to humans. That's why people can be in high contact, but there may not actually be any transmission.
Thank you so much.
So I think Javier Sanchez has a question in the chat while Isha, you were delivering the seminar. Why greater than 18 years old was used. Why that
Yeah,
age?
oh, for the survey. So that was a logistical constraint because we were doing, so this was part of my PhD work. And this was just, we didn't really have a good way of capturing children through like ethics and things like that, because they wouldn't necessarily all have phones. So we just used adult. We did ask questions. I didn't show it here, but we did ask questions about who else and went to the market with you. A lot of people, particularly women, would respond that children would go with them. But we didn't have a good way of capturing that. And we didn't feel like it's not a true contact, you know, like not like the Masong paper and trying to understand contact matrices. This was just trying to get an overall estimate. So it's definitely an overestimate for maybe children, but we just didn't have a good way of getting children specific estimates unless we were going house to house. And so we had to use a, you know, just for logistical constraints, we used a phone survey.
And Simran Sandhu has a question. Were you interested in spillover events within LPM settings alone or overall? If overall, why were the domestic settings excluded?
So we, it was not specifically LPMs. It's just, we didn't have a good estimate for what that value is at home. So that value at home, you know, to get chickens or whatever, someone in the household would have had to have gone to the LPM to get it. It's not like the way that people interact with the food system in terms of getting poultry and things like that from grocery stores is not the same. And so we use the LPM setting as our main exposure site because that's kind of where people would have acquired poultry in the first place.
We have two people raising their hands, so I'll start with Dr. Patrick Leeton.
Thanks. Great presentation, Isha. Really interesting, and congratulations on getting those survey data. I mean, what a great resource to actually be able to get to the bottom of some of the transmission dynamics. My question is for you is, so you have a model of spillover where you get avian influenza going from domestic poultry to people, and then you have a model of influenza transmission within a population, but just because it jumps to people doesn't mean that it's transmissible human to human, right? So how are you dealing with that in this model? I mean, and maybe the related kind of devil's advocate question is, why haven't we seen pandemic avian influenza emerge? I mean, even with the relatively low frequency of outbreak or spillover events that you're seeing, I mean, by now it should be all over the place given your model, right?
Totally. So this spillover model is not looking at further transmission. So it's just looking at spillover, like how many events or runs result in spillover. So in like the base case scenario for the low efficiency virus, out of the 1,000 runs, I'm trying to find the number. It was 9% of the 1,000 runs resulted in at least one case, which, and that's a great point. Like, why haven't we seen this? So again, this is where it comes into that theoretical component. We don't really have a good estimate for infection response efficiency, which is kind of a key driver here. These are probably overestimates. H5N1 is, as I said before, really well adapted to poultry systems, but it's not well adapted to the human sort of nasopharyngeal system. Like it's really well adapted to poultry GI tracts. That being said, this kind of work, the really aim for my work here, and recognizing that this is still preliminary results and preliminary work, is to help inform pandemic preparedness, right? Like if you're kind of thinking about these questions when a virus already emerges, you're already too late, you're already having spillover events. But if you can kind of see what potential spillover could look like and what levels of intervention or reduction you would need in things like the prevalence. Right now, the prevalence of AIV in poultry in Bangladesh in the markets, just in market settings, was about 50%. So it's pretty high. So, when you have this high level of contact between poultry and humans, and you have pretty high level of prevalence in markets and environmental settings in markets, these small little tiny events can accumulate together. And so I don't think it's specifically I'm not specifically looking at this is going to happen. We're going to see a huge change or a huge event happen because of spillover, and then further like transmission. It's more just to say, how do we think of interventions and what types of interventions are needed for different levels of potential transmissibility of a new virus, as opposed to saying this specific virus will emerge and have this level of transmissibility. Does that kind of make sense?
Oh, definitely. I think that's a great approach. I was just curious whether you'd gone the next step to see, somehow estimate the frequency with which those spillover events could then lead under different circumstances to sustained spread, which, I mean, it goes into another set of modeling, but I absolutely think that's a great approach and going to have some really interesting implications for management. Thanks.
Dr. Zhu, do you have a question?
Yeah. Okay. Thanks for the, in fact, very interesting talk. As Patrick just mentioned, it's really important. I realized the question he asked involved some of my questions. I also noticed, Chief, if you look at the chat, I see Simran asked a few questions about spillovers.
Yep.
Yeah. Maybe Isha, maybe you can see from the chat.
I can.
Those questions, in fact, what I'm trying to ask is, spillover represents, a broad concept, different kind of spillovers. So here in your study, like, if you can look at what Simran asks.
Yeah, so Simran Sandhu, she's asking, or he's asking, sorry. Did you break down your analysis by AIV subtypes? If so, do you have any interesting / significant results you'd like to share? Secondly, there are wild bird, domestic backyard bird interactions as well that can introduce avian influenzas within domestic settings. So any comments on that?
Yeah, so these are great questions. So we did not break down by AIV subtype. So again, this is more theoretical on what a potential, infection response efficiency could look like. And definitely there are important differences between AIV subtypes. So we know that, for instance, H7N9 and H9N2 transmit more easily to humans than H5N1. But we're kind of looking at this more theoretically. And then in terms of the wild bird domestic backyard interactions, that's also a really great question. So the focus here was on Dhaka City Corporation, or Dhaka DCC. And that's a very urban setting. And they just have a very different interaction. Like the ownership of backyard poultry in urban Dhaka is very low. So I think those type of questions, if we were looking at something across the country or in rural settings, would be really, really important. But in the context of DCC, most poultry interaction occurs through live poultry markets, as opposed to in backyard settings or having them in the home.
Yeah, I have a follow-up question on that. I was wondering about the molecular epidemiology. So are there any groups, yours or others, who are collecting nasopharyngeal swabs from these birds?
Yeah, so there's a lot of really great work happening in Dhaka and just generally in Bangladesh from folks in the UK at the Royal Vet College and LSHTM. So there's the Poultry Hub, which is a big collaboration doing a lot of work on this. And ICDDRB as well, which is a big group in Bangladesh, does a lot of work on AIV as well. So that's kind of where we've gotten a lot of our estimates for the prevalence in markets. So sometimes they're looking at specific prevalence in poultry. Sometimes they're looking at environmental settings. There's very low prevalence amongst AIV workers, which I think points to that fact of a potentially low transmissibility of these different types of viruses. But that's not to say that things might change in future. Like the point, I think that really the key here was to see what potentially could happen and what types of interventions are needed to prevent those type of spillovers in future.
Great. Joseph Baffy has a question. I'm not sure about what you meant by high interventions. Have you done a study on the impact of any interventions yet?
I think, sorry, I might be speaking a bit quickly or being not clear. So what we mean is that when we're looking at spillover, based on the modeling framework that we're using, an important component of this is the infection response efficiency, which is how efficiently a virus will transmit from an animal to a human. And this is like unknown, really. The only way to really get that estimate is to parameterize it to zoonotic spillover. So this has been done for things like Lassa or Nipah, where there's a lot more transmission events and you can kind of get a better estimate. But for something like H5N1, where there's so few cases, we don't know that value. And so we use theoretical values here based on what we've seen in the literature, what's been used for other AIV models to kind of say what would be a high efficiency scenario is like a potential virus that has an easier time transmitting versus a low efficiency scenario, which is a virus that would potentially have lower transmission potential. And then for each of those, we just ran 1,000 simulations. And then we also just did these reduction events for 5, 10, 15, 25, 30, 50 to see what happens when you put an overall reduction on in that not necessarily on the transmission event itself, but an overall reduction on spillover. So that could happen through reduction in prevalence, reduction in contact. We don't really have good estimates for, if you clean markets this often, this is how much you reduce the potential risk. So we just use these largely theoretical values to say, if you had a 5% reduction, which could come from a variety of different interventions, this is what you might see. If you had a 10%, 25%, etc. I see Amy is on the line as well, and who has been really lovely to work with on this. So I don't know if you want to add anything, Amy.
Well, I just wanted to ask a question because I think, there's a lot that you've been doing in this space. And one of the things that I think hasn't really come up yet is, Patrick talked about the idea of like spillover and then, risk of onward transmission is pretty low right now with H5N1. And so, we don't really see sustained person-to-person transmission outside of, these very rare kind of stuttering chains that happen. But the model you have is actually it's fit to human seasonal influenza also. So you can actually look at co-infections, which is a totally different sort of question. So I just thought maybe people might be interested in hearing more about the co-infection part, which you haven't really talked about today.
Yeah. So, and I see Natasha has posted that in the chat as well. Exactly. So because we have this spillover component that's integrated into a human influenza model, one of the things that we are also interested in looking at is that spillover or co-infection potential. Because, you can have all these spillovers, but the way that novel, viruses emerge is through recombination and reassortment between human and avian viruses that result in co-infection in the same host, right? And so we do kind of have that in the model. That's something that we're building in and kind of looking at. Again, it goes back to that theoretical component. We're looking at spillover, and then we're looking at potential spillover amongst people that have an influenza infection, a human or seasonal influenza infection. And so that's something that we're also looking at and trying to sort of tease apart, because really that compartment is where reassortment events would occur. Is that kind of where you were going or sort of alluding to, Amy?
Yeah, that's exactly it.
So I don't see there are any more questions or hands being raised. So with that, I would like to conclude our seminar.
Oh, we have a question.
Okay, yeah, we have a question. There you go. It's great. We have so much interest today. Pei?
Yeah, thank you, Isha, for this very interesting and informative talk. So maybe I'm not sure if you missed this question in the chat. Like I also have the same question. Like you mean like for the high interventions. So like if they have the higher infection pack, you mentioned there should be higher interventions. What if this be? So have you done a study on the impact of any interventions yet?
Yeah, so that's a great point. Sorry, I think the what we were kind of getting at here is that we don't have a specific intervention that we're looking at. We're just saying that interventions would need to be stronger, would need to result in, so for a potential virus that had a higher efficiency, you would need interventions that were stronger, like up to 50% reduction in either, prevalence of AIV in the poultry population or in terms of contact. So we didn't look at what that specific intervention is, because there's not really great empirical data on that. You need some types of RCTs to say what is the reduction when you have when you clean markets consistently, or when you do sort of market shutdowns, or there's lots of different types of interventions that have been done. I think in China, a lot of work's been done on closing markets, or like having rest days and seeing the impact of that. But again, a lot of that is we don't have specific values. We can see like what happens if we have a reduction in the number of days that people are going to markets. But for the context of this study, we were kind of being a little bit more loose, because we didn't want to be too prescriptive and say you need to do X, Y, and Z to see a reduction. It's more just saying if you did a combination of things that resulted in 25% reduction, this is the potential effect it would have.
Thank you for the explanation. So I have another question is about, like, you mean for the higher infection rate. So for this higher, you have the comparison for the lower one and the higher one. So this is from your data, like you get this estimate, or from literature, like
for the efficiency scenarios?
Yeah, for the low and the high.
We just use theoretical estimates from the literature. So that's kind of all the other components of our spillover model are empirically informed. So we have the number of susceptible people based on the census. We know the number of people that are in the setting. We know the contact rates, or an estimate of the contact rate based on our other components. We know the prevalence in markets, but we don't really have an estimate for that efficiency level. And so those are just not empirical, those are theoretical estimates from, and what could happen in different scenarios.
Okay, great. Thank you.
But I will say that this is very much work in progress. And, thank you all for your feedback and your questions and thoughts. And thank you, Javier. I think you just put something in the chat. I'll open that up as well. So this is really, something that we're kind of thinking through, and really just trying to use, we did this study, or it was really exciting to be in Bangladesh for a long time and do that study and get those estimates. So it's really just trying to use those to the best potential that we can.
Yeah, Isha, this is Javier. They did a great job. I just put the paper, I guess it was published using a different framework, but with the same idea, more a global estimate of the spillover. But I think they also put some parameter there that can be translated. And I think one of the interesting things for your work is maybe using that frequency exposure and see how they come up with these the estimate. I think that the conclusion are the same as your work, which is good. They also pose the idea, what about swine being in the equation there, and how much the risk and the spillover can be affected by including swine, which we know that is a big one.
Yeah, that's a great point. I'll have a look at this paper. I think I've glanced at it before. The one thing I will say that's a very specific scenario for Bangladesh and DCC is that swine is not very relevant. It's a Muslim majority country. And so
yeah,
it's just such a different, the mixing vessel sort of theory and things like that don't have the same effect in a country where swine is almost just, it's not really sold, it's not really available, it's not in markets, there's no real contact between poultry and swine. But that's a great point.
That's good.
Thank you so much.
Okay, I don't see any more questions. So with that, I would like to thank all the audience members for asking so many great questions and being so interactive. And a special thanks to Dr. Isha Berry for presenting an awesome work. Thank you so much. Goodbye.